Hey everybody, welcome to today's update on Daily IoT. On today's episode, I'm going to give you a demo of my debugging setup via Docker for my particle firmware. Now, I have written an entire blog post on this with step-by-step instructions for setting it up. I will link that down in the description, so if you want to set this up yourself, that's where you can get full instructions. This will not be a complete walkthrough from start to finish. For that, go to the blog post, you'll see the setup. This is just a demo of how it all looks and works once you have it set up to see the flow that you can get through Docker using GDB to debug your particle firmware. So let's take a look. Before I get started, I just want to remind you that I have done quite a bit of setup and preparation to get to this point. For more information about how to get to this point, see the link in the description below. It has a link to a blog post with full step-by-step instructions for how to set everything up. That includes doing things like building a debug version of your application source, setting up Docker for Mac to be able to talk to the debug hardware and things like that. And so that has all been set up. I have programmed the debug firmware onto my particle photon, and I am now ready with the debugger hooked up and attached to my computer to step through my source code. And so that is the point that we are at now. Again, for more information on that, see the blog post linked below in the description. All right, as you can see, I have my particle photon up and running. I've got the debugger attached. The green light doesn't mean anything at this point. And you can see that the D7 LED is lit up. That's because the debugger is attached. And I am breathing cyan, which means I am connected to the cloud and operating normally. Just because it's debug firmware, when you're running it in a normal mode, it does pretty much the same thing it would do as a non-debug firmware, and it's running your application. And so to show that, I have a CLI call here that just calls the FridgeEye device. I'm using an old FridgeEye photon here, and I'm calling digital read. Again, this is just the Tinker firmware that I have cloned into a sample repo for the express purpose of demonstrating debugging. And so it works pretty much exactly the same. The only change I made is that I restricted access to pins D7 and D6 because the hardware debugger needs access to those. And so if I run this, I should get a -1 response because, like I said, I'm denying access to pin D7. So I'm gonna hit enter. It's gonna make that call, and you'll see that I get a -1 response right here. But what if we want to debug that and see it in action? So what we need to do is I'm gonna put my photon in DFU mode. I'm going to hold down both buttons, let up the reset button, wait until it begins to flash yellow, and then see that there. Flashing yellow means I am in DFU mode. And now I am ready to attach with the hardware debugger here. And for that, I have this giant Docker run command. Now remember, you don't have to type this in every time. You can create an alias so that this is all just stored into like a debug project command. And so let me just briefly run through it. This isn't a Docker lesson, but we're gonna run Docker run, which is gonna create a new container from an image. The -ti says we're going to be in interactive mode. The --rm says remove the container when we're done so we don't have any artifacts hanging out. This device piece is what allows the Docker container to know about my hardware debugger. I'm then going to volume mount the particle firmware source as well as my application source into the container. For this, it's going to use this Maker Crew particle build image that I have created and that anybody is free to use that will pull down automatically if you don't already have it. And then inside the container, I want to run this arm-none-eabi-gdb executable with the rest of this being an argument to that. Now, you don't need to understand this. This will not change for your application. The only thing that will change is the volume mounts up here, wherever you pulled the particle repo down, as well as wherever your application source resides. The rest of this is just how you run it with this particular debugger, and it just works. So when we hit enter here, oh, I'm down in the wrong window, back up here. When we hit enter here, you can see it launches the GDB process. I'm still flashing yellow in DFU mode, but you can also see that now my debugger is doing some activity because it is connected to my photon and ready to go. To get started with your debug session, we need to restart our photon and halt it. And to do that, we're going to type monitor reset halt and hit enter. And what this will do is reset the photon, and you can see it'll say target halted due to debug request. And now we're just in normal GDB. And if you're new to GDB, I suggest you find a cheat sheet of some sort that shows you the different commands that you can run. This is all command line debugging, but very helpful once you learn just a few simple commands. And so I'm going to show you just a couple of them. So let's say I want to set a breakpoint in the setup function. That's the very first thing that's going to call as part of our code. So I'll type in break setup, hit enter, and you can see it says breakpoint 1 at. It gives you the address, and then it'll even tell you, oh, this is in your application.cpp file at line 37. Oh, that's really cool. Let's do another one here. Let's do break tinker digital read. That is the function that is called when we run this particle CLI call down here, this digital read. And so we'll do a breakpoint there as well. You can see breakpoint 2, and it's at line 63 in our application.cpp. At this point, we can just type C to continue. You can also type out the entire word. I suggest you learn the shortcuts. It makes things go quicker. So if we do C and hit enter, if you watch the photon, it's now going to do its normal startup, connect to the particle cloud, and now we've hit our breakpoint back over here in the window. And so you can see I'm at my breakpoint setup, but this isn't as helpful. It just says that I'm at line 37. It would be nice to be able to see what line 37 looks like. And to do that, we can just type another GDB command, layout split, and that's going to break the window up into this source code section. It's got some machine instructions here, and then our GDB prompt for us to type in commands. And so you can see right here, my breakpoint is at line 37. It even shows you the source with the comments and everything. So if I do N or next, you can type it out, but just N is the step command, so it will step in to, and you can see now I'm on the particle.function line here in my setup function, and I can step through and look at things, which is pretty awesome. So I'm going to go ahead and hit C again to continue. Again, it's going to reconnect to the particle cloud. You can see here. And after it connects to my Wi-Fi, it might just take a second there. And once it's flashing cyan, I'm again just running normally. And you can see here in the console it says continuing, and I'm just kind of hanging out, nothing's happening, and it's just waiting to hit another breakpoint. And so to do that, I can make this call again, particle call, Frigi digital read D7, and that should hit our breakpoint that we set earlier in Tinker digital read. So let's hit enter, wait for it to go up to the cloud and come back down, and boom. We are now at application.cpp line 63. You can see up here in the source view that the breakpoint has been hit right here, 63 in the code. Now there's some interesting behavior here. This is probably something for a GDB expert to explain, but if I hit next here, it's going to step in and then it's going to assign the pin number. This is where it parses out the command that you sent. In my case, it's this D7 to know which pin I want to read. But if I hit next here, and hit enter, it goes back up to the top. I'm not sure if this is due to optimization or things of that nature, but now if I just hit next again, it's going to bring me back down to that line, pin number. I hit next one more time, it's going to assign it. And then from our debug session, I can do things like info locals. And so after that parsing call, I can see that pin number is a local variable, has been assigned the value of 7, which is exactly what we'd expect based on how we called the function here. And so this is really cool. You can see at this point I'm going to return a -1. However, you'll notice down here in our console where we executed the command, it says function call failed, timed out. So it's not going to wait forever. The CLI has no idea that you're debugging. It just thinks, hey, this is taking way too long. Something must have gone wrong. So I'm going to say that it's timed out. But you can see how by doing this, you can get into your code and start stepping through, see what's going on. Again, once you've finished inspecting or seeing whatever you want to see, you can just hit C to continue, and it will go back to normal operating mode, and it will continue running as expected. And so that's just a very brief tour through how you can debug your firmware using GDB through a Docker container. Very low cost, $13 for this piece of hardware to connect to the particle photon to debug your firmware. Okay, so that's it. If I ever get into a scenario where I need to debug my puck firmware, that's all I have to do. Connect that up, run a couple of Docker commands, and I can step right into my code, debug through it, and I'm really happy with how that turned out. And so, question of the day, it's March Madness, and so who do you have winning it all in your bracket for the NCAA basketball tournament? Who do you have picked to go all the way and win it? Stick it in the comments below. I love hearing from you. Otherwise, I hope you'll tune in tomorrow. I have a pretty interesting update on the hardware report. I got that in, so I'll be talking about that, so you don't want to miss that. Otherwise, until then, I hope you have an awesome day, and thanks for watching Daily IoT, the show where together we're learning how to make the Internet of Things one day at a time.